Guys, we're going to talk about circles in an algebraic way. Of course, we know these things here. This point here is called the center. The green line here is the radius. The yellow here is diameter. You got this formula here that the diameter is 2 times the radius. Things like that. But we're actually going to not necessarily talk about this specifically, but the equation of a circle algebraically. Whenever you see x squared plus y squared equals some number, it won't say r squared, it'll be a number, but you should see an x squared and y squared. What that means is you have a circle at the center, with the center point here at the origin, 0, 0. And the radius is r. Now notice that it's always r squared. So the number you see is not the radius. You have to take the square root of the number at the end of the equation. Alright, so whenever it's x squared and y squared, that means the center is at the origin, which is 0, 0 on the Cartesian coordinate system. And the radius is the square root of the number at the end here. Now, I got a little hint here. You can graph a circle with the center and the radius. That's all you need. How? Well, you plot the center first, whatever the center is, in this case 0, 0, and count out the radius in 4 directions, up, down, left, and right. So based on that, let's do an example. Here's an example right here. We have, that equation, and so let's try that. Come on, do the thingy. The thingy. Well, it won't do the thingy. So, here we go. I'm going to graph x squared plus y squared equals 9. The first thing we need to know is what's the center. Okay? The center is 0, 0. That's the point 0, 0. Or, in other words, it's called the origin. So here's the center right here. Alright? So how do I know that the origin is 0, 0? Because it's just x squared and y squared. Okay? Now, the next thing we need to know is the radius. I guess I should write it right here. Radius. The radius is always the square root of the number that's on the equal side, on the right-hand side. And so the square root of 9 equals 3. Really plus or minus 3. And we can use both of those. But the way that it works is, a radius is the same distance around the circle. So a radius from the center, I'll just count to the right. 1, 2, 3. I count to the left. 1, 2, 3. I count down. 1, 2, 3. Notice how I count. I don't start counting this and say 1, 2, 3. No, everywhere you land, 1, 2, 3. And then I count up. 1, 2, 3. Now, it's very tempting, guys, to draw a diamond, straight lines. But you're supposed to try to round it off and make a circle. Okay, so I shouldn't see any diamonds. Alright, if we have to graph any of these. But that's how you would graph a circle. Very specifically with ordered pairs and points. Okay? With the radius of 3. You can tell that anywhere here that the radius is 3. Alright, now that's simple enough. But the radius, the center is not always going to be in the middle, okay, in the origin. And so here's an equation of a circle where the center is shifted or moved around. Notice that the radius is still r squared, so it's always equal the radius, okay? The issue is, where is the center? And so whenever you have something grouped in parentheses squared, that means you have a different radius. It's not at the origin. It's shifted. H and K are going to be numbers. You won't see an actual H and K in the equation. H and K are numbers, where the number that's with the X is going to be your X coordinate, and the number that's with the Y is going to be your Y coordinate. Or H comma K is the new point. Notice that the H and K are positive, and on the inside they're negative. They're not always going to be negative inside the parentheses. What that means is, when you look at that point, is that whatever the signs are of H and K inside the parenthesis, when you remove them outside the parenthesis, they change signs. And that's a true statement from math always. Whenever things come outside of parentheses, for the most part, they change signs. And so here we have another example of finding the center and radius. And I'll go ahead and graph this as well. And so let's do that. Let's take a look at that. Find the center and the radius as I look to graph. Okay, the first thing we need to understand is what's the center. Okay, now look at how this is written. The x minus 3 is in parentheses, so it looks just like this. That tells me that this number right here is the new x coordinate for my point. However, it's a minus 3, and according to this and what I just told you, that if it's a minus 3, I have to change the sign when I pull it out. Okay, so it's not a minus 3 or a negative 3 that I put right here. It's a positive 3. Whenever it comes out of the parenthesis and you write it as a point, you need to change the sign. Now let's look at the y coordinate. Notice that the y coordinate doesn't have a parentheses and squared. It's just y squared. So based on what we just did previously, hopefully you understand that that still means 0. Whenever it's just y squared or x squared by itself, that coordinate gets just a 0. So my new center is 3, 0. If you didn't understand what I just said to explain how I got this, then you should probably pause and rewind back a little bit, because I specify how I found that my center is now positive 3, 0. So what does that mean? That means starting at my origin, I go to the right, 1, 2, 3, and put my point there. Since my y is 0, I don't move up or down. So that's the new center. All right. Now, let's look at the radius. All right. The radius is always the square root of the number that's at the end. And some people will be tempted when it's a small number like this just to count out 3. No, but you always take the square root of the number that's at the end down there. So this means the radius is going to be the square root of 3, which also means that that's going to be a decimal. And it's approximately 1.7. So yes, I'm going to graph that. So how do you graph approximately 1.7? Well, I'll show you. It's an approximation. It's an estimate. So from here, if I go 1.7, that's 1 and almost 2. I'm comfortable right there. It's not 1, it's not 2. So about 1.7 is almost close to 2. So I'm going to try to do that same distance. 1 and 1.7 all the way around. 1 and 1.7. And then again, don't draw a diamond. Try to draw a circle. There you go. So I approximated that my radius is about 1.7, and so I had to guesstimate where about 1.7 was from this point. 1.7 goes to the right, down, left, and up. That's how you graph circles. Alright guys, this is something that you may not have to do. This is a geometry class, or these notes are for geometry, and this comes up a lot in Algebra 2, but sometimes your equation is given to you in a form that you can't just pull out the circle or the center and the radius. And so these are steps here that you need to follow in order to take something that looks like this and make it look like something that we can use like these here, this equation there. And so I just like to show you this. And again, this may not be something that you have to do in geometry, but it's trying to give you a heads up because there's some technical things in here that you may not have learned. So the first thing you want to do is kind of group all your x's and y's together. So I'm going to rewrite this as x squared plus 8x in the proper order, and then I need to add y squared to both sides. And when I add y squared, I can go ahead and leave a space there, and I'm going to say y squared minus 2y, and I'm going to leave a space there, and that equals 64. So what I did was simply rearrange the x squared and the 8x, so I just moved those around a little bit, and then I added the y squared because I want all the variables, every variable on the left hand side, and any constant or number without a variable on the right hand side. And so I wrote them in what's called descending order for the x's. I mean x squared and x to the first power. They're going down by powers, y squared and y, and I left a space there. Now, I'm going to do something that some of you guys who already had Algebra 2 know what's called completing the square. I'm going to take 8, I'm going to divide it by 2, and I'm going to square it. and that equals 4 squared, which is 16. So what am I going to do? I'm going to add 16 right here. But if I add 16 here, I also have to add 16 here on the other side of the equation. Okay, that's just the rules. I'm going to do the same thing with negative 2. I'm going to divide it by 2, and I'm going to square. That's negative 1, and that's going to be squared, so that equals 1. So I'm going to add 1 here, and I'm going to add 1 here. And you say, what are you doing, Mr. Freeman? Well, I am doing what's called completing the square, which you'll learn next year if you haven't had Algebra 2 yet. And basically, I've added these two numbers here, but I also had to add them on the other side because it's an equation. I just can't add something to one side. Now, why am I doing it specifically and separating the x's and the y's? Well, because whenever you do that, this factors, that's another thing that you're going to have to do a lot next year, down to x plus 4 quantity squared, I forgot to put my plus there, and plus y minus 1 quantity squared equals whatever that is, 81. That equals 81. Now notice what we have here now. Isn't this an equation that we can call a circle, that we can actually find that the center is negative 4, comma 1. Remember, you changed the signs. And the radius is square root of 81, which equals 9. Now, again, you may not have to do this. And I don't want you to get bogged down thinking that we have to learn all this. We probably should already know this. However, I just want you to know that they get a little bit more complex than just those two examples that I showed you already. It's a little bit more complex than that. All right. And now I turned on something that don't need to be turned on. And I need to go back to my notes. So these right here are the steps that I just found. Move all variables to the left and all constants to the right of the equal sign. Group x's first and y's next on the left hand side. That's what I did. Complete the square on both if needed and add term to both sides, and then I factored. And so I basically followed those steps, and that's how I got the last answer. But this is where we really need to be. How to find the center, how to find the radius whenever you have an equation of a circle. All right, that's pretty much it. And again, if you got questions about this, I'll be more than happy to answer them. These are completing a square and factoring are two things that you definitely want to have a grasp of as you start looking toward Algebra 2. Alrighty.